the previous videos, we mentioned about producing the structural key plan, which is on basis of the architectural drawing, where there are a lot of considerations that governs the layout of your beams, as well as the locations and orientations of the columns. We have also demonstrated how the key plans are produced in relevant to the topic we discussed on the column. Now we will proceed our discussions with the foundations. You know that other than ground floor, first floor and roof beam, there will be also the key plan for the foundations, as you need to clearly indicate what kind of foundations that you are using, what are the size of the foundations, where are the foundations located. Normally we have foundations below a column. The most ideal design is every single column will have one foundations, so that the loops can be transferred from the upper story, going straight to the foundations and then subsequently to the ground. We don't want the forces to be transferred from the upper story to the lower story, and then later to the columns and then to the foundations. You are supposed to design the minimum path of the load distributions to the foundations and then to the ground as measures to ensure the economical design. The longer the path, more stress and forces will need to be resisted by the structural element. That means additional reinforcement will be required. Therefore, if it is possible, try to avoid the stiffness and try to ensure that continuous column from the top to the bottom of the building. When we talk about the foundations, we will need to consider the loads being distributed to the column at each level of the building, and as the accumulations of the forces that will need to be resisted by the foundations. In common practice, there are two major types of foundations, which are the footing and the pile caps. Footing is a shallow foundations. It is normally used when there is a good soil bearing capacity, which this soil bearing capacity can be determined from the soil investigation report, which is normally known as the SI report. In the case that you don't have sufficient soil bearing capacity, that means deep foundations will be required. This is where you need pile foundations, and there will be pile caps to group the piles together and to equally distribute the loads from the buildings into the piles and then to the hard strata below the ground. When you have sufficient soil bearing capacity and it is dependent on your design, you know that you can use the footing, that you need to provide sufficient areas of the footing so that the soil is not being overstressed, and also you can actually take full advantage of the soil bearing capacity to support the slab which is in contact with the ground. In this case, you don't have to design the slab to be suspended slab. It can be non-suspended slab, which you only need to provide the minimum reinforcement bar to control the cracking of the slab, and the slab is fully supported by the soil. However, when you deal with the soil low capacity, for example soft soil or peat, you don't have sufficient bearing resistance and your footing size will be unrealistically big. Most likely you require to drive pile into the soil until it reaches to the hard strata underneath the ground. And you will need to consider the total looks taken by the foundations. There will be a wide range of the piles with different capacity, and there are several types of piles. There will be RC piles, there will be bakao piles, which are timber, and there will be span pile, where the piles are pre-stressed and is able to carry a higher capacity of axial load. This one, it will be very much dependent on the loads acting on the foundations, and you should need to decide the suitable piles to be used. As far as the local practice now, timber pile now is not applicable, especially for the building part. Infrastructure probably, but the building part is definitely not. That leaves you to two main options, which is either the RC piles or the span piles. The RC piles are normally lower capacities, and the span piles are normally higher capacity. You can actually acquire the catalog from the internet given by the supplier. You can seek the local suppliers for the catalog. They have their standard size as well as the standard capacity. Based on the range of the loads acting on the foundations, you will need to decide which pile to be used. For typical development of residential, office and commercial building, which is less than 3 story, normally we will use the RC piles. Unless the building story is much higher, where the loadings is extremely high, and if you use the RC pile, the numbers of piles become unrealistically large. This is when you're going to need these span piles. Of course, there are also considerations. Because the piles conditions, it can be end-bearing and it can be frictional piles. This one requires proper design, which you're going to learn it in the geotechnical engineering, which in this case, and especially for the local now, peat is one of the most common soil in the region. Therefore, most likely is going to be pile foundations. And when you design for the pile foundations, in fact for all type of the foundations, including the footings, you need to be careful with the center of gravity of the columns. The center of gravity of the columns should be in line with the center of gravity of the foundations. Let's say now you have combined footing. You need to be mindful with the centers of the loads. The meaning of combined foundations, that means your foundation now are taking the loads from more than one column, because the columns are placed quite near to each other, which if you use the pad footing, they may clash into each other. In this case, when they clash into each other, it will be better for you to construct the combined foundations. And now the center of gravity of your combined footing should be in line with the centers of the loads as a resultant to the two columns that they use to support. This is something that you need to take into considerations. Now let us look at the typical key plan for the foundations. There will be grid lines, which is in line with the grid line as per the architectural drawing, and normally this grid line is more meaningful to the columns, where the columns are typically properly in line to the edge or to the centers of the grid line. This is for the contractor to easily locate the locations of the columns. But you know that you need to design the foundations, be it pad footing, be it pile caps. It should be in the center of gravity of the column, which is more specifically referring to the center of the loads. If this is only one column per foundations, that means automatically the center of gravity of the column will be the center of the load. This will need to be in line with the center of gravity of the foundations. That will lead to a situations that the foundations are normally at the offset distance from the grid line. This one you need to be very careful. What you see here, this one is a column. which fits nicely to the edge of the two grid lines here. However, the center of gravity of the column, it will be here. Therefore, your center of the foundations should also be the same place as the column. This will lead to an offset distance from the grid line. You will need to clearly indicate the locations of the offset distance. And this offset distance, you can calculate it geometrically based on the dimensions of the foundations. And these dimensions, you can refer to the coarse reinforced concrete design too. There is a chapter regarding the foundations. Now that you have indicated proper locations of the foundations, which is very much dependent on the numbers of piles, and the arrangement of the piles should be in the conditions where the centers of the reactions should be in line with the center of the gravity of the pile caps. That means now you have three centers must be in the same location. The center of load from the column, the center of gravity from the pile caps, and center of reactions from the piles. They should be in line. This is to ensure the structures are stable and there is no eccentricity of the load. Next, you will need to group the foundations together into limited number of groups so that it is easier to manage. And you will need to make sure every single group of the foundations must at least have the capacity higher than the looks it is designated to. And you will need to provide details for the foundations. This will be reflected in the schedule of foundations. Provide the reinforcement bar, provide the dimensions, indicate the anchorage from the foundations, as well as the lapping line, and so on so far. This is about it regarding the foundations. Remember, you need to choose appropriate size of the foundations, particularly in terms of the piles. Different sizes of the piles have different axial capacity, normally given in the tonnage or in kilonewton. This can be acquired from the catalog of the manufacturers.